Good morning, ladies and gentlemen, on this wonderful Thursday morning, April the 2nd, 2020. Hope you guys are all doing well, and today we're going to be talking about exponential functions. It doesn't really follow well from the complex numbers we were talking about yesterday, but it is next in our unit, and it's also very important to what we're doing today, or what's going on in the world today with, viruses and pandemics and how things change very rapidly in a short amount of time. So let's just jump into it. Alright, ladies and gentlemen, let's make sure that my pen is working, because I will need something mightier than a sword to get all this stuff done. Ink color, there we go. Maybe I should have gotten this done before, I started writing, but who cares? Anyways, thing that we need to remember that all exponential functions are in the form y is equal to a times b to the x. Writing that on the board. Y is equal to a times b to the x. Now, if this is your first time dealing with functions or exponential functions, one thing that is fundamental about exponential functions is that your variable is in the exponent. That's why it's called an exponential function, meaning that it's going to change very rapidly. Obviously, that's your variable. As I just said, a is what we call your starting term, or at least it's what we've been calling starting term in my class. And b is what we call a rate. What are we going to be multiplying by, or what are we going to be dividing by each time? Exponential functions don't do a whole lot of adding or subtracting. They're based entirely on multiplying and dividing. And as we can talk about in today's stuff, multiplying and dividing is a whole lot quicker than adding and subtracting. It has a whole lot greater change. So right now, I want us to be able to understand this form in order to figure out and put these values back into these problems. Like for this one, I've got a y value of 64, a rate of 2, and a variable value of 4. So I want to figure out what is this a value that makes this whole equation true. Well, if I want to figure this out, let's rewrite it simplified. 64 is equal to a times, now we need to figure out what 2 to the 4th power is. That's the same thing as 2 times 2 times 2 times 2, which is 2, 4, 8, 16. So that's going to be 64 is equal to a times 16. Well, if I want to figure out what a is, I can do the opposite of multiplication here. Since it's a multiplication, opposite of multiplication is division. So 64 divided by 16 is equal to a. Now 64 divided by 16 should be equal to 4. So we can say that 2 to the 4th power times 4 gives me 64. Alright, next one. Now this one is pretty straightforward. I have my starting term, I have my rate, I have my variable value. The only thing that I'm missing is my y value. So, writing this out, y is equal to 2 times 1.5 to the 4th. Now 1.5 to the 4th very quickly, I believe, is it's 5.0625. Now we will probably get involved with a lot of decimals and fractions today. So if you don't have a calculator, I could recommend a few online applications or a few websites that would have a calculator for you. But I've got y is equal to 2 times 5.0625. Well, multiplying something by 2, you just double everything. So 2 times 5 is 10. And 0.0625 times 2 is 125. And that is totally a 2. Maybe I should circle my answers. Circles his answers, he says. It's totally not a circle. Anyways, moving on. 3.125 times 10, 3.5 is equal to 10 times b to the 5th power. Well, this one involves a couple steps. I need to undo a 5th power, which means you have to do a 5th root. But first, let's divide. 3.125 divided by 100 should give me a point. Move the decimal place over twice. 0, 3, 1, 2, 5 is equal to b to the 5th power. Well, that just means I need to do a 5th root on both sides, which is not going to be pretty whatsoever. But when you do that, you should get b is equal to roughly 0.5. It might be a little bit different, or you might have to round on your calculator, but it should be 0.5. Now, because of the little snafu that I had yesterday, I am going to double check this one. You can never be too careful when you're doing some math. Yep, when you divide 3.125 by 100, it actually rounds that up to 0.0313, but it's the same thing, essentially. 5th root of 0.0313. Yeah, you get 0.5. All right, ladies and gentlemen, for your check for understanding, I want you to take 5 seconds, pause the video, and try to figure out which one of these is built incorrectly, or which one of these has a wrong setup, or will not give you whatever the value is over here. Once again, take 5 seconds, pause the video, work on it. And that is time for me. Ladies and gentlemen, it turns out it's this one and this one. My students will often tell you that I will most likely, for multiple choice on one of these, check for understanding, there's typically more than one, especially if it says which of the following. All right, A is incorrect, C is incorrect. This should actually be equal to about 7.5085, and this one is actually equal to about 337.5. Alright, now this just comes from understanding how to build this. Do you take your b value, do you take your rate, are you multiplying it by itself a certain number of times, or are you raising it to the 9th power on your calculator? Are you doing that a correct number of times, and then are you multiplying by your starting term? That's all we're doing right now. We're going to finish up with what we call exponential growth and decay. Very related, it's very relevant to what's happening today, because viruses work on an exponential growth form. One person can infect 10 other people, who can infect 10 other people, who can infect 10 other people, so on and so forth. So kids, parents, definitely pay attention and stay inside. All right, so first things first, I want us to be able to figure out how do we build this equation. A petri dish of bacteria was placed in a cold environment. The number of bacteria decreased by 10% per minute. If it started with 5,000 bacteria, how many remain after 10 minutes? So we have 3 numbers. We have a 10%, a 10 minutes, and a 5,000 bacteria, and that's all we need to build this. So we need to figure out what's my starting term, what's my rate, and what's going to be my value of my variable. So y is equal, well, if we're talking about bacteria, probably the one that says 5,000 bacteria is probably my starting term. It's how many bacteria I'm starting with. So I'm starting with 5,000. Now, when I made this problem, I just kind of threw a number in there. I don't know if that's a lot of bacteria. I don't know if that's a little bacteria. I'm not a biology teacher. So, times something to the something power. Well, if we see this, it decreases by 10 minutes. Decreasing implies direction, whether it's getting bigger or it's getting smaller. This is definitely getting smaller, so I'm going to assume this 10% is my rate. But if I were to assume that, I mean, it would make sense. But if you put in 0.10, you would actually be wrong. Because what this is asking for is how many remain. Not how much did we lose, but how much remains. So, one thing we have to be very careful when it comes to exponential forms is that typically on exponential growth and decay, it's a times 1 plus or minus your percentage, plus or minus your percentage. Because if you have a rate of 1, there's no growth. You're not getting bigger, you're not getting smaller, to the x power. So if it's decreasing by 10% each time, each minute, it's decreasing by 10%, the amount that remains, well, what's the opposite of 10%? 0.9%, or 90%, right? 0.9. So I'm actually going to multiply not by 10%, but by 90%, 0.9, to see how much remains. Now, if I was talking about how much I'm losing, well, then I would use 0.10. But I'm asking about how much is left in the equation after the minute's over. So, oh yes, also pretty easy. But if it's 10 minutes, well, time is typically a variable. So to the 10th power. Now let's crank this out. It's 5,000 times, well, 0.9 to the 10th power, if I did this correctly, get that decimal out of here. 1743.5. So 1,743.5. Oh, flip. Done goofed that one. That should be my final answer, actually. Yeah. Anyways, it's going to be 0.34. Yes, ladies and gentlemen, when you have a decimal to a power, it's not going to be larger than 1. But when you multiply 5,000 with 0.3487, that is going to be equal to 1,743. 0.5. 1,743.5. That's how much bacteria remains after 10 minutes. Which is pretty good. That's like a good number of dead bacteria. So, final thing we're going to talk about today, or at least we're going to go over, is to check for understanding. Once again, take 5 seconds. Let's just read the problem. Solve for the missing variable. Make sure to read the question carefully. Well, the missing variable is going to be y in this case. Build your equation. A wildfire is burning in the countryside. For every hour it burns, it consumes 3% of the countryside. If it is started on a 10,000 square mile field, I guess. Not an English teacher. Please don't judge my grammar and my word choice. And burns for 13 hours. How much land is left? So, this is just like the other problem. I need to build my equation, my exponential growth equation, considering a starting term, my rate, my variable. What I'm going to be trying to find is my y value, how much is left. So, y, that's a very ugly y is equal to, so, here's how you do it. You've got 10,000 square mile. That's how much land you're starting with, right? So that means this has got to be 10,000. Well, when you look at this percentage, it consumes 3% of the countryside for every hour it burns. But we're talking about how much land is left, so am I going to use the 3% or am I going to use the opposite of 3%? Definitely the opposite of 3%. I'm going to be using a 0.97. And how long does this burn? 13 hours. So, once you have this and you crank it in, your answer for how much countryside is left is 6,730.27 acres. I don't know what the unit of measurement for acres, I don't know how to write that, so I'm just gonna put the whole thing acres. No, it's square miles. I do know how to put square miles. It is square miles. Anyways, ladies and gentlemen, this has been a blast. Tomorrow, we're probably going to be talking more about exponential functions. They're very important. I love to talk about them because it's all puzzle building, essentially. I hope you're listening. Make sure to leave a comment or subscribe if you're having any issues. You can definitely hit me up on the website, which is on the YouTube page. One thing I will also say is that I have received direction from Manassas High School that we will be starting classes in Microsoft Teams. Now, I'm not entirely sure how Teams is going to reach everybody when this YouTube channel can't, but it's definitely going to be a place where we're going to put up these videos, we're going to put up a website, and I'll definitely use it as a place where I can put any assignments or any PowerPoints that need to be put. It's definitely a better way to organize what we have. Ladies and gentlemen, I hope you have a great Thursday, and stay safe.